In this lesson, we are going to talk about all things connected with classes and objects related to those classes. First, let's talk about what it means to have state and behavior. The state is the current value for all of the instance data for the object. So whenever we create a class, every time we create an object of that class, each of those instance variables will be created for each of the objects that we build. And the state describes the values of the variables for that object. Behavior describes the methods that that object can call. We have an idea called encapsulation. And encapsulation is essentially when everything is bundled up into one bubble, so to speak. And we think of it like a need to know. We don't really need to know how the methods work. We just need to know what the names are so that we can call them on the variable. The constructor is going to set up all of our instance variables for the object. And once we have created the object with the constructor, then we can interact with those variables using these instance methods. Public and private are two keywords that we will use quite a bit. The word public means that the class is usable everywhere. The word public is going to mean that the methods can be called within your client program, such as your driver program, so that the client can call those methods. The word private means that it's only accessible within that class code, within that .java program. So let's say, for example, we have instance variables. Instance variables should always be private, and those are private to protect the data. We can have public methods, and these public methods will go ahead and be called in your driver program so that we can access the private data with permission. We can also have private methods if we would like, but those private methods cannot be called outside of the class. Static is another keyword that we will see in Java, and static is what we refer to as a class variable, or if it's a static variable, or if it's a static method, that is a class method. And static variables are going to be shared among all instances of a class. Some examples of where we've seen static variables used, or when we had a counter that counted up all instances that were created, or when we had, for example, the next number to create when we were making our new book objects, and we wanted to keep track of the next book number that we should use when building the next book object. The static variable will be initialized outside of the constructor, and it will be updated within the constructor. And we can also make our constants static final if we'd like. Static or constants don't have to be static. However, if they are static, then that means that one set is created for all objects, rather than having every single object make its own personal copy of all of the constants that would be used by the class, which would be more efficient. All right, when we're talking about our methods, this is our anatomy of a method header. So first we have our access specifier. Typically most of our methods are public. Then we have our return type. If the method returns nothing, we say it's void. We have the method name, which starts with a lowercase letter by convention, and then we have any parameters. If the method doesn't take anything, then the parameter list would be empty. A special method is our constructor, and our constructor is going to create an object of the class. The name of the constructor has to be the same name as the class, and there is no return type, as in you don't even put the word void there. You can have multiple constructors, which allows you to create objects multiple ways. The default constructor would have no parameters. It typically just initializes numbers and strings to be 0 and quote, quote. We don't have to make a default constructor unless we're specifically told to do so. Next thing that we'll see are get and set methods, and these are the accessor and mutator methods, and these are used to allow us to interact with these private instance variables, so that way the client program can adjust those values. Now, when we talk about static methods versus instance methods, an instance method is going to operate on a specific object. So you're going to use it once an object has been created. So in this case, oops, that should be a lowercase b. In this case, I made the bank account object b, and then I called the method b.deposit. So deposit was called upon the variable b. And here the method getBalance was called upon the variable b. The methods deposit and getBalance only make sense if you call them upon a specific object. Now, a static method, on the other hand, or a class method, performs an operation for the entire class. So you don't need a specific object in order to call this method. In this case, you would call the method by using a class name. So an example would be when we talk about our math class, when we would say math.square or math.abs. Or if you are calling a method within a driver program, all of those helper methods need to be static, and there's no class name or dot notation in front of them. And that's because no object is made. Those methods are just called. So to build on this a little bit more, a static method is going to have the word static in the method header. There's no implied object, and because there's no object connected to the method, you cannot refer to any instance data or call any instance methods. Static methods can refer to other static methods or static variables. And if a static method is called outside of a current class, you would invoke it using the class name. So for example, if I had a static variable to count the number of bank account objects, and I had a static method, then what I could do is I could say the class name, bank account dot, and then the static method name, get num accounts created. If I was calling this method within the bank account class, all I would have to do would be say get num accounts created. Method overloading. So this is when two or more methods have the same name in the same class but use different parameter lists. The compiler will be able to tell which method to call by looking at the arguments that are used when the method is called. The return type is irrelevant, and this is because when the method is called, the compiler is not looking at what's going to be sent back, it's being looked at what's being sent in. So this is done a lot with constructors, but that's not the only way that it could be done. When we talk about the scope of a variable, we talk about the region in which the variable or method is visible. So instance variables, static variables, and class methods belong to the scope of the class, and those are going to be directly visible inside the curly braces of the class. So you can refer to them by name or method only without that dot notation. A local variable is defined in a method or block of code, like a loop, and it's only visible within the curly braces. Once those curly braces are left, that variable is gone. If you wish to have two variables with the same name, one that's local and one that's instance variable, the local variable takes precedence, but this is really confusing, so please don't do this. This keyword. So if you have an instance method being invoked by a calling object, we can refer to it with the word this. This basically says the implicit parameter, meaning this object is calling this variable or this method. We can also say I want to print this, meaning it's printing itself. In this case, we basically just talk about how the method would work. So here, if I were to call p.printPerson from my client program or my driver program, inside the printPerson method, when it says print this, it's printing itself, and itself would be the object that called the method, which would be p. Reference versus primitive data. So primitive data is going to be ints, doubles, and booleans, and those are stored differently than objects. So when variables are created, it allocates a certain amount of memory to be set aside, and each variable has its own slot, and changes to one do not affect the other. So in this example, I have two integers that were created, and I created b with the value of a. So essentially what happened is the value that was in a, the value of 3, is copied into b. So now both b and a are equal to 3. And now when I say b equals 5, this changes the value of b, but it does not affect the value of a. All right, we will go ahead and go through this example in class together and just take a look at how we trace out these different references. So we will continue those two slides in class. All right, formal versus actual parameters. So when we call a method, the formal parameter is what the variable is called in the method header. And within the method code, the words password and amount are what will be referred to. The actual parameters, this is what's passed in when the method is called, wherever it may be called. And that's because the method, when it's called, you could actually use lots of different things. You could plug in variable names, you could plug in numbers. So the formal or the explicit parameters are what are used when you write the code, and then actual is what is used when the code is actually run. So pass by value. Pass by value essentially says when you pass primitive values, what you're doing is you are copying the value that is there and you are sending it into the method. And the method is going to use this temporary copy and it is going to do whatever it does with it. And then when it leaves the method, then that copy is gone. When that parameter that we are copying is a reference to an object, the process is the same. However, the difference is that this local variable that's created is also a reference variable. And this parameter that is copied is the address of the object. So any changes that we make to this copy of the address, we will see once we leave the method. This is similar to how if you have your house key and then you go to the drugstore and you make a copy of this house key and give it to your friend, and your friend were to come over to your house and do whatever they may do, and then you were to come home, you would see the results of whatever they did because the key that you gave them was an actual key to your house. It was the same key. It was a copy of the address, a copy of the key that got into your home. Now the object class, every class that we write is a subclass of object, and they all inherit the toString and the equals method. Now the toString method is by default going to return the address in memory of where the object is stored. It is common for us to override the toString method so that if we print the variable's name, then what will be called instead is the toString will be called in its place and it will display out information related to the object. So our toString method is going to return a string, and if we print an object, that string that is returned will be printed. The equals method is going to check for equality. If we use equals equals to compare objects, all that will happen is we check to see if they are aliases and they point to the same place in memory. If we want to check for equality of their contents, the programmer needs to write an equals method, and they can decide what it actually means for those two objects to be equal. All right, so our string class is actually a sequence of characters, and a string literal is an instance of this string class. String objects are immutable, which means that no methods change them after they've been constructed. You can override the contents of a string, or you can concatenate and create a new string by adding to it, but they are immutable, meaning that they cannot be changed. So if you take a look at these examples I have here, we can see that the plus operator is a concatenating operator. And if we do string plus a number, since there's no way to add letters and a number, this will just concatenate. And so that's why this turns into the word and then 6-5 after it. Here, on the other hand, since I have numbers adding first, numbers can mathematically add. And so then this will turn into 11 plus the string, and I will see 11 Susie. compareTo is a method that you are expected to know how it works. The way that compareTo works is it is going to compare using the ASCII code, and it will first compare numbers, then capital letters, then lowercase letters. And it will return either a negative number, a 0, or a positive, depending on the values of the strings. So this is an important one for us to go ahead and review. The calling object, if the calling object, the one before the dot, comes first, meaning comes earlier in the alphabet, then it will return a negative number. And this is because it subtracts these characters from these characters. If the two values are equal, it will return 0, and if the first value comes later, it will return a positive number. Here I have listed a list of methods that we need to know from our string library. Most importantly are substring and index of. So make sure that you read over this and review those. Substring method, remember if we do end index minus start index, that will tell us the number of characters in the resulting string that is being extracted. Okay, the remaining slides are things that we will talk about in class, but we want to look over the wrapper class, the math class, and math.random. So we will talk about these in class. So I encourage you to read over these before then and have questions ready. Thank you.